Imagine your computer as a classroom, and each student in that classroom is a process, and the teacher is a CPU. So every student wants to answer, but the teacher can call only one at a time. So who goes first? That's what process scheduling is all about. Which process gets the CPU first? Hi everyone, my name is Sethi, and today I'm going to simplify one of the most fascinating concepts in operating system, process scheduling. A process scheduler is like a teacher's timetable. It decides which student speaks when. So every student gets their turn efficiently. In the same way, the scheduler decides which process uses the CPU. The goal is to make the system fast, efficient, and fair. So let's explore three major scheduling algorithms of process scheduling. First come, first serve, shortest job first, and round robin. Each one has different way of managing time and fairness. First come, first serve. It's like waiting in a canteen line. The first person to arrive gets served first. Let's take an example. Suppose we have three processes. P1 takes 5 milliseconds, and P2 takes 3 milliseconds, and P3 takes 2 milliseconds. The CPU executes in the same order they arrive. First P1, then P2, then P3. It's fair and easy to understand. But it has one problem. If the process takes too long, others have to wait. This is known as convoy effect. Now, what if the teacher decided to ask the students who can answer the quickest? That's the idea of short job first. Here, the CPU chooses the smallest burst time first. So if we have three processes, P1 needs 5 milliseconds, P2 needs 3 milliseconds, and P3 needs 2 milliseconds. The CPU will start with P3, then P2, and finally P1. This method reduces the average waiting time because shorter processes finish quickly and free up the CPU for others. But there's a catch. If a short process arrives when the long process is running, should we interrupt the long one? That's where the difference between preemptive and non-preemptive SJFs comes in. Now imagine the teacher gives every student 2 minutes to speak. After that, the turn passes to the next student. And once everyone gets their chance, it starts from the first again. That's round robin scheduling. Here, every process gets a small fixed amount of CPU time called time quantum. For example, if time quantum is 2 milliseconds and there are three processes, P1, P2 and P3, the CPU will execute them in order. P1 for 2 milliseconds, P2 for 2 milliseconds and P3 for 2 milliseconds, and then back to P1 again. This continues until all of the processes are complete. It's fair and it ensures every process gets regular attention, especially useful in multi-user systems. Alright, here's a quick challenge for you. If you have three processes with burst time 4, 6 and 8 milliseconds and the quantum time is 2 milliseconds, how many rounds will it take for all of them to finish? Try drawing a Gantt chart yourself. It's a fun way to understand how round robin works in real time. Pause here and give it a try. So let's recap. First come, first serve. Simple and fair, but can make short tasks wait. Shortest job first. Efficient, but sometimes long process have to wait too long. And finally, round robin. Fair for everyone and used widely in real-time systems. In the end, the best algorithm depends on what kind of classroom or system or managing. Scheduling isn't just about CPU time, it's about balance and fairness. Thank you for watching, and remember, great teaching is all about making complex ideas simple and inspiring others to explore. See you in the next video.